Alright guys, it's Cypher here, and you guys have probably been wanting an update on the Arc 3. Ever since the Arc 2, I've been kind of growing as a channel, and I'm at the barrier of 100 subscribers, but 2 people unsubbed, and I'm at 99, so it is what it is, but what we're looking at right here is an incredible difference between the Arc 2 versus the Arc 3. The Arc 3, which is this one right here, uh, also has a very different architecture compared to the Arc 2, where the Arc 2 worked as kind of like working upward, like all the different layers. This one, everything is just more of interconnected, and it's so much faster, except for storage, of course, because RAM, to have this huge block of storage, makes it a lot harder to, you know, really make it fast like everything else. So first, let's look at the ALU for this thing. So the ALU uses a carry cancel adder inspired by Benny's Cube, one of his videos. I added a subtraction module and connected up a comparison unit as well. Or these two circuits would allow me to the first thing is I can invert B, and the next thing being I can take A and B and then I can compare them, and then it's stored, or it's output here. And the ability to do that is pretty good. Other than that, if you look at the cache, it uses 16 bytes of dual read cache. And I've set it up in a pretty compact way. It's absolutely pistonless, by the way, which is what I hated about the Arc 2, is because it slowed the computer down so much. But because there's no pistons so far in this design, this can run a lot faster. And I am still working on this here. I inverted these. I'm working. The decoders are really a pain, and I'll get into the decoders for the RAM in a minute. But it's coming out all right, actually, the computer overall. But the main breakthrough is the ability to send the B output through the bus of the A output without them interacting, and then it outputting into the B bus. And it goes back and forth and whatnot. It's pretty good. A new addition to this design is the program memory inside of the CPU rather than the storage. The the Arc 3 no longer takes its commands from RAM. Instead, it takes its commands directly from the CPU itself. This is like directly inspired off of real-life computers, which store programs inside cache to allow it to run faster. And this design allows it to completely eliminate the need to access RAM for any given program. You load a program into the CPU, into this program memory. It's got 32 bytes of it, and once you've loaded it, you can run that program. It also allows you to really run complicated programs if you were to design them. To have, like, say, a main game loop, and it'll be possible to take commands from RAM, although it's going to be a little hard to really get that working, so I'll figure out exactly how I want that to work. I haven't gotten to the ROM yet, but I want the computer to have like 16 to 32 bytes of system ROM, which will store, like, the main system data. Like, how every computer has firmware, and that's kind of what it will be. It'll be a hardware-based firmware. The only time where it'll be modified is if the user decides to change the programming, or if, say, I create a new world, or not the new world, but create a new software for the world. Another thing is, I do plan on really supporting this one rather than the Arc 2, because the Arc 2 never really... It was very successful. A lot of people watched the video, over 500, but I never got enough, I never get a world download. And I definitely needed to do that, especially with the realm, but just haven't yet. Honestly, I should probably do that after this video. I also got to show you guys how to program for it and whatnot. But yeah, other than that, let's look at the storage. Just letting you know, before I get into it, it's literally only a few blocks wider than the exact same size of the storage of the Arc 1. The Arc 1 had 64 bytes of RAM, and it was in this area. It was about this tall, maybe a little shorter, like by a block or two, and it was about the same width. Now, the Arc 2 literally had the exact same size as this, but this doubles the storage. Like as the Arc 2 doubled the storage space in the same area from the Arc 1, the Arc 3 doubles the storage space or the storage in the same area from the Arc 2. This thing has 256 bytes of data, and each of these bytes are easily visible. This whole thing is a byte, and it's very simply stored and very simply accessible, and you can count 256 out of all of these numbers, out of all of these squares. They're very easy to see. And also to save on space, the input bus and the output bus are shared. This is because you'll never need to read or write at the same time. You'll only ever do one of those. So because of that, I have a system here. It'll allow me to read the computer, like read from the RAM, or write to it. It'll never do both. And I can share the buses in that case. Also, here's a very interesting point of interest. This is going to be located right behind the user interface, right behind the input, so it's immediately inside the CPU, unlike the previous designs. You're obviously seeing so many improvements where things are just so close together, so that's good. But this thing has two inputs from the RAM and from the ALU, but it has several outputs. It can go to RAM, it can go to cache, it can go to program memory, all of that from here. It also has an input from the user interface when I build it. So all of this passes through this bus, and this bus goes everywhere. It naturally goes into the cache for a value loaded from here to be saved into cache if I were to want it to be. But it can also go here. It's locked right now. If I come down here, oh, I never put the yeah. Let me just show you guys. This can go through the cache busing and make it to the program memory. There we go. And still, it does not interact with any of the busing it passes through. It's only 2 ticks laggier getting through this, but honestly, that's fine. But yeah, it goes all the way down. I've got 2 bytes here that are the longest to address. The last 4, actually, not 2, because it's 1, 2, 3, 4. It shares an output bus, but there's 2 separate input buses for either side of the program memory. The decoder was particularly difficult to hook up because of the setup. I had to split it here, and then I had to create the right system, and ooh, it was just a pain, but I got that working without too much difficulty. So it's a 5-bit decoder, and I started working on the counter. I'm still going to be working on that. I'll be done after a little bit. It's going to be several registers, like the addressing, which goes to RAM and which goes to program memory, are addressable directly from program memory and cache. Although cache is not directly hooked up yet, so I just gotta figure that out real quick, and then once I do that, it'll be real easy. And other than that, that's pretty much all I have built so far. I do have the GPU planned out. I've been working on the ZGPU Gen 2. Designed a little contraption for that. It allows it to take your input, your data. It can actually work off of sprites. It takes that data, that visual data, and can send it anywhere on screen but it is first saved into the registers, which are then very quickly printed on screen, so you can get an entire screen update in about 16 frames or 16 ticks. I think it would actually be 32 ticks if it's 2 ticks per screen, but actually since it's memory, it could actually be 16 ticks. So, yeah, that's your progress update on the Arc 3. Thank you for watching, guys, and we'll try to get some progress done today, and then get the video out to you on the actual not reveal, but release of the project. Thank you for watching, everybody. I'll see you in the next one.